Welcome students, myself LAKSHMIKANTH from Department of Electronics. In this video, I am going to discuss about the basic concepts of a microprocessor. By this video, students get information about the basic components of microprocessor. Students gain the awareness of microprocessor and the real-time applications of microprocessors. Microprocessor acts as a brain of a computer. It accepts several instructions and generate an output. The microprocessor is a combination of digital circuits. The digital logic gates like AND, OR, NOT, and so logic gates are used in these microprocessors. The output of a digital logic circuit depends on the present and current input. But in the case of a microprocessor, the output of the microprocessor depends on the instructions given by the user or the programmer. These are the applications of microprocessors. The microprocessors can use in the basic calculators to the high-end applications and IoT applications and so on. The microprocessor is a digital integrated logic circuit, acts as a CPU which handles several components surrounding the microprocessor. The first microprocessor introduced by Intel in 1971, 4004. It is an 8-bit microprocessor. Later that 8008, 8080, 8085. 8085 is the most famous microprocessor by the Intel. Later that 80186, 286, 386, 486 Pentium processors, core processors, multi-core processors are introduced by the Intel. Not only Intel, there are so many other manufacturers are also introduced various types of microprocessors. For example, ARM. ARM is the most popular microprocessor which are used in smartphones and tablets. Inside the microprocessor, these are the several components are contained in the microprocessors. The first one is ALU, Arithmetic Logic Unit. Arithmetic logical unit which performs various types of applications, various types of operations like arithmetic operations, addition, subtraction, multiplication, division, and logical operations and or not XOR. Control unit. Control unit which organizes all the components inside the microprocessor. It accepts opcode from the memory location. Then that opcode was sent to the CPU by the program counter. Then it to instruction register. Then after that instruction decodes by the CPU and the processed output, that means the output is the generated output sends to the output ports or to the peripheral device or etc. Simply the control unit which organizes all the components inside the microprocessor. Registers. Various types of registers are available in the microprocessor. The registers are nothing but a logical circuit which holds information either in the form of zeros and ones. The width of the register defines that either it is an 8-bit processor, 16-bit processor, 32-bit processor or 64-bit processor. Here for example, 8085 is an 8-bit processor. That means the 8085 internal registers mostly 8-bit wide. That means it handles 8-bit of data at a time and processes 8-bit of a data and it generates result in 8-bit. Suppose if it is a 16-bit processor, then it handles 16 bits of data at a time and processes that 16-bit data. That means if the internal register width is higher, then it can handle more number of bits at a time. Memory interfacing. Whenever the processor wants to access information either by ROM memory or RAM memory, then it needs an interfacing unit, that is memory unit. By mapping the memory with the help of a memory interfacing unit, the microprocessor able to access information whichever located in the external memory, that means RAM and ROM. Clock circuit. Clock circuit acts as a heart of the microprocessor. It generates clock pulses, periodical clock pulses. The clock circuit which synchronizes all the components inside the microprocessor. The operational speed of microprocessor may also depends on the clock frequency. A crystal oscillator is used as a clock circuit. If the clock frequency is higher, then operational speed of microprocessor is also higher. System bus. Various types of system buses are available in the microprocessor, that is address bus, data bus and control bus. Address bus which carries address bits from the memory, which carries address bits. That means whenever the microprocessor wants data access the information from any I/O device or a memory device, then the particular memory address accessed by the microprocessor through the address bus. Suppose if the microprocessor wants to send information to and fro by the microprocessor, then it sends the data bits through the data bus. Similarly, if the microprocessor issues a control signals like I/O operations, timing operations and control signals, then all these information was sent through the control bus. Flags register. Not only the components like ALU, registers, system bus, there are few other components are available in the microprocessor. Those are flag bits register or status register. The status register which holds the statuses after the arithmetic or logical operations. This status register which indicates the current operation or what tasks that were done by the processor, represented here. I/O port. Whenever if the processor wants to communicate information to and fro either from peripheral device or memory unit, then the processor sends the data through the input or output port interrupts. The microprocessor always communicate with so many peripheral devices. Whenever if any peripheral device wants a service by the microprocessor, then the microprocessor must need to attend that interrupt. So here the peripheral device generate an interrupt and that interrupt request received by the microprocessor. So all these things are handled by the interrupt handler. An interrupt handler assigns these interrupts to the interrupt service routine. In this way, the microprocessor which resolves all those interrupts are generated by the peripheral device or any other external devices which are connected to the microprocessors. So here the interrupts are again categorized into software and hardware interrupts. All those interrupts are resolved by the interrupt handler. So this is the end of the video about the basic concepts of microprocessors. Thank you.